Today we're going to go ahead and learn about type 2 polyatomic uh, compounds and how to name them or write the formula from the name. So to be honest, they're just like binary, but instead of looking at the um, above the staircase for the nonmetals, we're looking at our polyatomic ion sheet. So let's go ahead and look at uh, put our charges in. So when we write the formula, we have to put our charges in, and remember that when it's type 2, there's a Roman numeral that actually represents the charge of the metal, of the type 2 metal. So this is iron 3, so it's a +3. We go to bromate, and if you don't know what the charge is, just go to your packet and go to the very last page of your packet, and you'll get this right here, and you'll see bromate is a -1. It's BrO3, and it's a -1. So you see it right there. Okay, so let's go back here, and we know that it's a -1. So now we're going to crisscross, and so I know I need 3 bromates, but I only need 1 iron. So we're going to go in here and we'll put a symbol for iron. Now again, the symbol for iron is Fe. It's right here. Let's make that just a little bit bigger so we can see it. So it's right there. Okay, so we're going to put our capital E, Fe. And then I need bromate. Now, do you remember? But I need 3 of them. And if you remember the rules about polyatomic ions for type 1, again, if we have more than 1 polyatomic ion, we got to put parentheses around it. So we're going to go ahead and put our parentheses in. Then we're going to take a look back at our bromate again, BrO3. So we're going to put BrO3 and put our parentheses back. And then we have to go ahead and put our number of bromates that we have, this number right here, right there. So we're going to put it in as a subscript as a 3. There's our formula for iron 3 bromate. Let's go ahead and do copper. Again, copper is a +1 because of the Roman numeral. Cyanate. Let's go ahead and look at our polyatomic ion sheet. Cyanate is right here, and it's also a -1, OCN. Okay, so that's a -1. They already cancel each other out, so I only need 1 of each one. So we're going to put in our copper as Cu, and then we go back to our polyatomic ion sheet. Look at that. Cyanate is OCN, and we're just going to put OCN. Copper 1 cyanate. Now here's one that's unique. I have pumice perchlorate. Now pumice is not going to be on your polyatomic ion sheet. We don't know what element is, but what I can tell you that is if we go to our packet and we scroll down to, there's an old version, prefixes, we'll find it in there somewhere, right after right here. Okay. Let's go ahead and go over here. Find pumice. Do I find pumice? Lead right here. And if we go up here, us is going to be this column, so it's going to be a +2. So I know that that is going to be a +2. And then I can go over to perchlorate. Perchlorate here is a -1, ClO4. And that's going to be a -1. So that means I need 2 perchlorates, but I only need 1 lead. Okay, so lead is Pb according to our over here, according to our periodic table. And then we need 2 perchlorates, so I need parentheses again. So we put in our parentheses, and then let's look at perchlorate. Perchlorate is right here. It's going to be ClO4. I'm going to put ClO4, then our parentheses, and then we need to put in the 2 from right here as a subscript. So that's really lead 2 perchlorate or plumbous chlorate. I'm going to throw one of these in here every once in a while. That's just to let you know that there is an older way to do it, and you might see that every once in a while. Let's go ahead and go down to our naming of the compounds. Now in these, remember at type 1, we just name the compound, but type 2 we can't because The metal is we don't know what the charge of the metal is. So we have to figure out what the charge of the metal is. And we have to work our way backwards, just like we would with binary ones. So we come over here and put our charge for MnO3. So we go to our packet, we go and we find MnO3, which is right here, manganate, MnO3. It's a -1. Okay, so we go back to that. We know that that's going to be a -1. Well, I have 3 of them, so my total charge for manganate is going to be -3, which means that my total charge for nickel is going to be a +3. I'm going to divide that by the number of nickels I have, which is 1, which means that my nickel is going to be a +3. So we're going to call this one nickel. If I spelled nickel right, let's see if nickel, N-I-C-K-E-L, yeah, N-I-C-K-K-E-L. So it's nickel, and then parentheses 3, and then it's manganate. I'm not sure I spelled that right. Right here, manganate. That is, hey, we got that one. Let's go to the next one, number 12. Okay, we have SO5, so let's go to our packet, SO5. SO5, there's SO4, but you remember that, and I don't have there's SO5 per sulfate. I remember that if I can't find it in the 8 group, I look at the pers is means one more oxygen, so it's a -2. So we'll go back into here, and this will be a -2. And since I only have 1 of each one, I have 1 per sulfate, and I have 1 chromate. So that means that this one has to be a +2. So we're going to go over here, and we're going to put in chromium 2, and that was per sulfate. Let me double check that again. Always need to double check. Per sulfate. That's correct. Okay, that's how we do that one. Okay, let's go on down to 13. I have SN, which stands for tin. Okay, and then we have C2H3O2, which I'll go to my polyatomic ion. It stands for acetate. We know the charge of acetate is a -1. So we go back over here, and we can go back. We know that that's a -1. I have 4 of them, so my total charge is going to be -4, which means that my charge for tin has to be equal but opposite, +4, but divided by the number of tins we have, which is 1. And so my charge for tin is going to be a +4. So we're going to call this one tin 4 acetate. Okay. And you do the rest of them pretty much the same way. If you need help, remember to ask myself or Mrs. Neer, okay, or any other person that's in the classroom that understands what's going on. Hey, as always, go Mohawks. Elsa out.